guys, welcome back to my channel. In today's video, I'm going to be continuing my discussion on functions. So in my previous videos, I discussed how to identify functions given a relation and some characteristics of functions. And in today's video, we're going to be discussing, well, how do you express functions? And the answer to that is function notation. So function notation is a very efficient way to represent multiple different functions simultaneously while also indicating their domain variables, which is just their x values. Right, so we're going to basically analyze this given function k of n, and so this is already in function notation if you didn't notice. So we would just call this function k, which is represented by this by the first kind of letter right here. You see right there. So we can just call this function k. And so what we're going to do is we'll notice that our independent variable is just going to be x, or in this case it's n, sorry, and our output values are just computed based off of this rule, which is -3n squared plus 12n plus 8. So this is how we get our output values, or our y values. All right, so basically we have two kind of sub-questions. So we have part A and part B. And so for each of these, we're kind of just computing k, our value of k, based off of different input values. And so the really neat thing about function notation is it's basically just a substitution guided process where you can just sub in different input values to get a different output value each time. All right, so it's pretty straightforward. Whenever you see like an n or your independent variable, you're just going to sub in your new value, which in this case is -3. So we'll just do that. So we can read this as k of -3 is equal to -3 times -3 squared plus 12 times -3 plus 8. And so all we need to do right here is just simplify to figure out what our output value is. So this is just equal to -3 times 9 minus 36 plus 8, right? So this is just equal to -27 minus 36 plus 8. And once we do the math, we can add these together and we get -55. Alrighty, and so k of -3 is just equal to -55. And so another way to express this is we can express this as a coordinate point, right? We can express this as like a point on a coordinate plane. So we take our x value, right? Because coordinate points are just in the order of x, y. So we take our x value, which in this case is -3, because that's what we sub in for n, and we take our output value, which is -55, and this is how you would express it as a point. All right. So let's move on to part B. So in this case, instead of just like an integer value that we sub in, we're actually subbing in more of like a expression. In this case, it's 2t minus 3, right? So same kind of substitution process here. Instead of n, we just put in, or we sub in 2t minus 3, right? So k of 2t minus 3 is just going to be equal to -3 times 2t minus 3 altogether squared plus 12 times 2t minus 3 plus 8. Right, so the first thing, we can simplify what's in our parentheses, right? And so we're having like a rule right here, right? So a minus b altogether squared is the same thing as a squared plus 2ab plus b squared. I'm sorry, this is actually a minus 2ab because it's a minus b, right? All right, so in this case, a squared is just going to be 4t squared. And then our -2ab, that's just going to be equal to minus 12t. And then -3 squared, that's just plus 9, right? We can just distribute this 12 right here. So we get a plus 24t minus 36 plus 8, right? So all we have to do from here is just distribute and simplify. So we can distribute this -3 to this parentheses right here. So we get -12t squared plus 36t minus 27 plus 24t minus 36 plus 8, right? So now all we have to do is just combine our like terms, right? So we look for our t squared. We only have one term, which is -12t squared. We look for our t's, which we have 36t and 24t. So it's going to be plus 60t. And then we have -27 minus 36 and positive 8. That's going to be similarly to part A, it's going to be -55, right? So this is going to be our answer. And just to kind of let you know, because this is not like an integer value and it has like a variable in it, we can't put this as a coordinate point. Okay, so let's move on to our second and last example. All right, so in this case, we're given g of x equals 4x plus 3 all divided by x minus 2. So for part A, we have an input value of 7, and we just need to figure out what is the output value. In other words, we just need to figure out what is g when our input is 7. Right? So we can just sub in 7 for x. Whenever we see x, we put in 7 instead. So it's going to be 4 times 7 plus 3, and then we have 7 minus 2. So this is just going to simplify to 28, which is 4 times 7, plus 3, and then 7 minus 2 is going to be 5. Right, so 28 plus 3 is going to be 31 divided by 5, right? And this is going to be our answer. And so remember, our answer is basically our y value, right? So this is just our y value. So if you wanted to, you could put this as a point. So our x value is 7, and our y value is 31 over 5. And you can always remember this because this is like the output value. This is the value you get once you put in a number. Right? That number we're putting in is our x value, and the number we receive back is our y value. Right, so let's move on to B. And again, similarly to the previous question, this is an expression with a variable t in it. Right, so anytime we see x, we just put in our new input value, which is t plus 2. Equals 4 times t plus 2 plus 3, and then this is going to be all over t plus 2 minus 2, right? So we can just simplify from here. So we can distribute this 4 to t and to 2. So we get 4t plus 8 plus 3, all divided by, if we have 2 and negative 2, these cancel out to be 0, right? So we just remain with our t at the bottom. Right, and then if we simplify the top, we get 4t plus 11, all divided by t. Right, and so this is going to be what g of t plus 2 equals. All right, and thank you guys for watching. I'm going to be posting a lot more function videos so you can like understand the world of functions, and that's going to be under my Algebra 2 playlist. So thank you guys for watching, and see you guys next time.